Hello everyone, welcome back to the stream. We are on day 968 for our community streaming challenge, and we're back working on the CM4 USB 3.0. So I kind of want to do some mapping. So I believe, just at a brief look at this, these two are practically identical. They're both made by Waveshare, and so the same components are used on both, I believe. I can see most of it. I think I'm gonna go with the actual CM4 board to do the analysis for the routing, just because it doesn't require this weird like 12 volt rail. I don't have to go through a PCIe connector. It's kind of directly connected to the CM4. So I feel like rather than having to route through here, through the main board, through this daughter board, I'd rather just have it all in one place. This schematic I found is from Seed Studio. They actually do have the VL805 on here. So I'm kind of glad I saw this. It's going to make my job a lot easier. The one thing it doesn't have, or the one thing it has extra on here that I don't think is necessary, is Seed Studio puts all these like isolators in place. I don't want to deal with that. It appears that Waveshare uses just a couple of capacitors to do the noise cancellation. And I think for the use case I'm going to be using this for, I'm not worried about it. I've been using this and stress testing these boards for quite a while, and they've never failed on me, so I don't foresee any issues that I would come across. I have no idea if Seed Studios is better, or if it's just a different approach, but less components is better in my opinion. I don't need anything unnecessary. Most of the USB devices I'm going to be using are going to be internal. I'm not going to be stringing giant cables out from the back of it, so I'm not too worried. So I'm going to go ahead and see if we can start mapping this board out. I'll probably grab this chip at least to sort of validate, make sure these values are right. I'm only going to be able to check the resistors, not the capacitors, because you need to remove the component in order to do that. So without having the, like, I know there's a data sheet for this. Somebody grabbed it and stuck it online. Yeah, this is a confidential one. I don't know if this is, yeah, this is the same one. It gives me the pin mappings. While it says confidential, people just went ahead and published it. Okay. I don't know if this has more or less information than previous, but whatever. It seems close enough. At least it gives me the package size. So I'm mostly just going to be mapping this board out today, and then figuring out where to go from there. Let's see, 88 pins. Was it 88? It's a QFN 88s. 22 pins on each side. This is a QFN 68. VL 800. This is the 800. This isn't the 805. The NVIDIA forum had it. I know that. Okay, this is the one I wanted. The 805. Whatever. I don't. Fine. We will use that. That's okay with me. I'm not gonna stress out about it. Okay, so this is a 68 pin. Thought it looked different. I have talked to the company. Well, I haven't talked to the company. I did send the company an email to see if I can get hold of these chips for my purpose, but I've heard nothing back. I'm gonna have to go with Pi Foundation route. But while I am not under a confidential agreement, I will go ahead and use every bit of data material I want and go ahead and freely share it. I am under no obligation. All right, let's go ahead and get started. So I'm just going to pull this off to the side because I don't need this right now. I don't even need this out here. Like this, elementary. Go ahead. I don't need you. This page seems okay. Other half I need is down here. Must be 3 header. Don't care. Tabs RxTX. I actually got 2 of these. down to, we'll call this what, 3 and 4? Yeah, let's do that. Wow. It's sloppy, but it works, so. Oh well. I will eventually have to wire this up. But for now, this is fine. Okay, so it looks like it already has the capacitors on it, so I'm not too worried. So those are probably by requirement. The others are probably added for noise reduction. So this says PCIe. photo. Try it. There we go. It's a little blurry, but it will actually do quite nicely. So, solid color, no outline. Alright, so I need to confirm 5 volts first. So 5 volts is always carried by standard USB, which means there are 4 connectors. That's good. Those should not be connected, and that should be good. One of these is ground. That's ground. So this is 5 volt. Turn that around so I'm aware. And I think one of these is 5 volts. Yeah. The hell? Okay, there we go. Okay, good. So this chip doesn't run on 5 volts. It runs on Let's see if I can zoom the camera. Bring it all the way forward. It's not the greatest, and I don't want to set up the other camera for now. Ground. Let's use like a brownish color. You know, green is ground. That's the standard that I can get behind. And usually the center of these is the same pin. I don't know what that is, so I'm just going to make it purple. It could be, that's a good point, that actually could be the 3-volt regulator. What is it? Can I read it? AM something. AMS 1117. AMS 1117. It is a 3-volt regulator. It is adjustable. Voltage out. Output voltage. Where do I put the voltage in? VDD. It has both power sets. Okay, there's a VSUS33. And then there's a VDD. VDD is 1.05 volts or something like that. But the VSUS33 is a 3.3 volt line. So looking at the data sheet, for the dot. Good. Vsauce would be 3 down. That's a 3-volt line. Further down, it doesn't have it. This is the 1-volt regulator right here. This is the 3-volt regulator. Which makes sense, it's bigger because it's actually used for a lot more. I'm gonna make that yellow. There's a 3-volt wire here. Side where all the pins come out, I believe is this side. Clock comes out from the top. Where the spot is on this one. Is there a correlation? TX3. Positive, negative. It is, it's mirror image. That's really confusing. The whole thing's mirrored. Like you're looking through the board. That's a whole level of pain I don't want to deal with. Okay, so the side I want to look for is over here. There's the 3-volt I just checked off. There's another few at the bottom. Is it also flipped vertically? It shouldn't be. SMI, yeah, SMI is on the right of the bottom, so that's correct. Three. this is the same. Oh, it goes through a couple of resistors. Those ones aren't going to be right. The one midway through the board. That's right. 1, 2, 3, 4, 5, 6. It's on the 6th. It could be, I could be completely off as well. Yeah, I had another power outage. That's why all my tabs have disappeared. Honestly, I was gonna stream from my laptop at a completely different place, but it's worked out. Let me put the arrow on the board. It's mirror image. I want to make sure I remember that. And because we're getting power shortages, we're gonna go ahead and do that. Okay, 3 volts. Also goes up here. And it appears as though there's an indicator. No? Must be something else. These are, well, are they grounded? Yeah, they should be grounded. I didn't doubt that for a second. So I see these going like straight in, but what are these ones? It's the 2 outer ones come off of way out. So according to this is the TX, positive and negative. So TX is these pins over here. Yeah, that goes there. So those TX pins make a lot of sense. Ground is usually this one. Yep. This all looks the same. I'm wondering if this is given to them. CS, SCK. These corner ones here should be on the side of the other one. Okay. So on this chip, it's SCK. SCK should be the last pin on this chip. Yep. The one next to it should be SI. Oh, see, so it should be the one below that. Yep. SO should be this one right next to the voltage line. That should be pin 2. Yep. Which leaves chip select is the last part. Chip select should be the last one. So as long as this is pretty close to here, alright, as long as this is close to this point, I shouldn't have any issues. Now, I don't know what this set of things does. It almost seems to run through it. Now, it could be a bunch of 0 ohm resistors just to pass something over, but there is a diode here. A lot of these are 3 volt based. Capacitors are. So this is probably a set of decoupling capacitors. No. The hold and right seem to be connected. The right protect is connected somehow. Right protect is hooked up to, well, this is a test point, that's not going to exist. It does have a resistor on it. And the other side of that resistor goes to VCC. Oh, hold reset. There are 4 items there. One is a capacitor. 3 of them look like a resistor. But one of those could be a diode. I believe this one is a decoupling capacitor. That's the decoupling. That's VCC. That's VCC. That's ground. How would miso be hooked up? Okay, so miso has something hooked up to it. I'm not sure why. Hold. It's just to decouple it from the ground? Okay, well I got all that mapped out to what's there. It's different than what's here. This exists. Hold reset and write protect have resistors. So write protect and hold. They're connected to VCC. Yes. It's PISO. There's nothing on SO or SI. So that's something different. That could be related to the chip. The chip may require it. Why do we place a series resistor in the MISO signal of an SPI interface? What purpose does it? What's the purpose and exact functionality of the series resistor? Modern logic families have very strong output drivers and can produce signals with edge rise and fall times in the nanosecond scale. This is often undesirable unless you want to analyze all of your PCB traces or RF transmission lines, which is a pain in the ass. We solve this by adding a little series resistance in the sending end of the line such that it both absorbs the reflections and slows down the rise and fall times by forming an RC filter. Sometimes you can see a pair of 15 ohm or so resistors where the line splits. They serve a similar purpose, but help dampen the resonance due to the T structure. This is often seen in a single-ended clocks. For more information, see high-speed signal propagation, advanced black magic with a read. What's the value of it? 100 kilo ohm. And they thought 50K seemed high. $10K for the one coming off of Right Protect. $10K. $10K matches. The other side, same thing. That one's 100K. Such strange values. Could just be anything that works. It's just they were very specific on that. They could have used the same. These all seem to use 10Ks. They used 100K in a couple of them. I mean, the goal is to use 100K and 0.1 microfarad. Kind of know where all this stuff goes. This was interesting to explore because I know more about it now. I don't know what this bit is, other than maybe it's all this stuff over here, especially with this thing. BL18, BLM 18PG 121 SN1T. It's a ferrite bead. Huh. I've never used a ferrite bead on a piece of electronics before. That's kind of what that looks like. I suppose it kind of does look like a capacitor, resistor, or diode. It's apparently on the PCIe, between the PCIe and the DCD 3-volt line. I don't even know where this would come from. Maybe the reference voltage? Interesting. There's something on this side, somewhere in here. It could be part of VDD. Alright, my eyes are tired. I'm gonna call it quits there. Thank you all for tuning in. I don't know. I have somebody in mind. Let's go to Ray Vile Mods. Alright, well, with that, thank you all for tuning in. We will pick this back up again tomorrow. I want to see if I can just completely clone this board. Other than that, day 968 of my continuous streaming challenge complete, and I hope to see you tomorrow. Bye.